So in today's video, we're gonna do a task which revolves around calculating the increase in cell surface area provided by microvilli. But before we're gonna run through the task here, which I've done beforehand, let's talk about the function of microvilli. So microvilli significantly increase the surface area of the cell membrane. And since diffusion occurs across the cell membrane, having a larger surface area allows for more molecules to diffuse into or out of the cell at a faster rate. And this is particularly important in cells involved in absorption and secretion, such as those lining the small intestine and kidney tubules, where efficient diffusion of nutrients and waste products are essential. Okay, so this is what is written here basically. So to calculate the increase in cell surface area provided by microvilli, we need to base the calculation on the diameter measurement that can be calculated from figure 3b as well as the frequency of villi. So here we have figure 3b. We need to calculate the diameter from figure 3b, and the frequency in figure 3c I've counted to be 355. So there are 355 microvilli. And then lastly, the height of microvilli is measured in figure 3e here, figure 3a, excuse me, to be approximately 3 centimeters. And now we can use this information to calculate the increase in cell surface area provided by microvilli. So, of course, we've measured the microvilli to be having a height of 3 centimeters. Now, that is the same as 30,000 micrometers. However, they tell us that figure 3a shows an electron micrograph magnification of x 10,000. So we need to divide that by 10,000 to give us the real height of the microvilli. So that is what I've done here. So 30,000 micrometers, which is the height I've measured, we need to divide it by the magnification, and that gives us the real height of the microvilli to be 3 micrometers. We do the same exact thing with the diameter of one microvilli. So one microvilli has the diameter of approximately 10,000 micrometers, but they say here that in figure 3b, the magnification value is x 100,000, okay? So we need to divide it by 100,000, giving us the real diameter to be 0.1 micrometers, okay? Now, I want you to understand that we can think of microvilli to be a cylinder with a height of a specific value and a radius of a specific value, which I've calculated and measured to be this, okay? And since the surface area of a microvilli is determined by this equation right here, we can simply put in our values, and that gives us that the surface area of one microvilli is 1.05 square micrometers, okay? However, we want to calculate the final increase in cell surface area provided by microvilli. So this basically means the surface area of all the microvilli put together. So we need to multiply one microvilli surface area with the frequency of microvilli, which I've counted to be 355. So that is what I've done here. So we come to the conclusion that the surface area is 372.75 square micrometers. However, they also tell us here that the section runs approximately parallel to the surface of the cells, so we're talking about figure 3c, and the area depicted corresponds to approximately 6 square micrometers. So the surface area is increased from 6 micrometers squared to this, so 378 squared micrometers. Now we can divide this value here, so actually it's 378 by 6. So the increase of surface area are 63 square micrometers per 1 square micrometers. So basically, the microvilli all put together here increase the cell surface area of by 63x. Okay, so this is a little task to understand, the whole function of microvilli and the fact that microvilli increase the cell surface area of the cell membrane, which then can allow for diffusion to happen at a faster rate.